The goal of this lecture is to help you understand what DHCP is and how it works. Before you can understand DHCP, you need to understand static IP addresses. A static IP address is manually assigned by an administrator, and as the name suggests, it does not change unless it's manually changed. In order to configure a static IP address, you must know the basic TCP/IP settings for your network. Things like available IP addresses, what subnet mask to use, what gateway to use, and optionally what DNS server to point your computer to. If you enter an invalid setting, your computer will not have network connectivity until you fix the configuration issue. Dynamic Host Configuration Protocol, or DHCP, is a networking protocol that allows a particular server to assign TCP/IP configurations automatically to client computers on the same network. In the Windows world, you need to install the DHCP server role on a Windows server in order for it to have this functionality on your network. A DHCP server will automatically configure the IP address, subnet mask, DNS server address, and gateway of a client computer, which is any computer on the network that is attempting to use DHCP as its network configuration. The configuration that DHCP assigns is not permanently given to the client computer, but instead it's leased to the client for a certain amount of time. Once a DHCP lease has expired, the client computer must reach back to the DHCP server and renew its existing lease, or it must obtain an entire new configuration and lease. Before DHCP was used, system administrators needed to go to each computer and manually configure the TCP/IP settings before it was on the network. This was bad for several reasons. The first was that it takes a long time. What if you have thousands of new computers? Secondly, there's large room for user error. What if an administrator assigned the same IP address to two different computers? It would be the equivalent of someone in your neighborhood having the same home address, which is obviously a terrible problem. We're going to look at how a hotel operates to help you understand how DHCP works. Johnny is taking a trip and has arrived at his hotel. He walks inside the hotel and asks the clerk for a room. The desk clerk then looks in his registry to see which rooms are available and finds that all the rooms on the top floor are closed because they're being repainted. This is an example of a DHCP exclusion. It's rooms or IP addresses that cannot be handed out to clients. The clerk finds that the first three bottom rooms have been reserved, so he can't give those rooms to Johnny either. This would be an example of a DHCP reservation. The people aren't in the rooms yet. The IP addresses are not taken necessarily, but they cannot be handed out because they're reserved for other people or other computers. Now, just because an IP address or a room is reserved, it does not mean that it's not in use or it is in use. All it means is that no one can go into this room or use this IP address because it's reserved for another client. Now, the clerk also notices that room 104, 105, and 201 are occupied, so he can't give him any of those rooms either. And this would be an example of computers just taking IP addresses from DHCP as they're available. Finally, he sees that he can give Johnny room 202 for 1 week. Now, the 1 week would be equivalent to the DHCP lease. You can specify when you configure DHCP how long client computers can stay in a room or they can keep an IP address. Okay, by default, I believe it's 8 days. That doesn't apply to those who reserve IP addresses. Reservations in DHCP are indefinite, and our DHCP lease does not apply to the reservation. Now, finally, our clerk sees that he can give Johnny room 202 for 1 week, or the lease duration, whatever we configure in DHCP. Johnny accepts the room and goes inside. The clerk now updates his registry to note that there is now a person in room 202. So the next person that shows up at the desk is not going to get room 202. Okay, DHCP does the same thing. When it hands out a client IP address to a client, it remembers that it gave this IP address to this computer and will not hand it out again to another computer. At the end of the week, if Johnny decides he wants to stay in the hotel, he's going to have to go back to the clerk and ask for another week. Now, the clerk can either give him another week in his existing room, or he can assign him a new room for another week. DHCP works very similar to this. When a client computer's DHCP lease expires, it comes back to the server and it either gets an extension with his existing IP address, or DHCP hands it a whole new IP address and a whole new lease. DHCP works very similar to how our hotel works. Administrators may specify the range or scope of IP addresses that are to be supplied by DHCP, as well as excluding or prohibiting certain IP addresses from being assigned to clients, just like our hotel clerk did for repainting the rooms on the top floor. You may also set reservations for specific computers. You could reserve the IP address 192.168.0.10 for the MAC address of the server ITFDC01. Only this server would be able to get that IP address from DHCP. This is different from manually configuring the IP address because we are going to configure the IP address from the DHCP server and not the client computer. If you have a computer that is configured to use DHCP, but it has an IP address starting with 169.254, this is referred to as a private IP address. It means that the computer was unable to find a DHCP server on the network, so it assigned itself that IP address. Now let's take a look at the technical explanation of how DHCP works. In this example, we are only showing two computers and a switch. Right now, the Windows workstation is not plugged into the switch. Since it could not find a DHCP server, it has assigned itself a private IP address. Once we plug the network cable into the switch, the client computer begins broadcasting a DHCP discover request. The request is sent to the entire network in hopes that the message will reach a DHCP server. A DHCP server will be listening for this request. Once it receives a DHCP discover request, it will send back a DHCP offer. This includes all the TCP/IP settings like IP address, subnet mask, DNS server, and gateway. Once the client receives the DHCP offer, it will send back a DHCP request to the server. This message lets the DHCP server know that the client wants to keep the settings that were offered by the DHCP server. Finally, the DHCP server will send back an acknowledgement message stating that it understands the client computer is going to keep the settings that it offered. The computer will now accept the TCP/IP configuration and its work with DHCP is done. Now let's recap exactly what happened. We can memorize this process for discover, offer, request, and acknowledgement with the acronym DORA. The client sends out a DHCP discover message and the DHCP server responds with a DHCP offer. The client requests the offered settings and the server acknowledges the request. So you might be asking why we'd ever want to use a static IP address. Well, remember that one of the settings that DHCP can automatically configure is the DNS server? This configuration would specify an IP address, basically a static IP like 192.168.1.10. What if the DNS server used a DHCP and its IP address changed from week to week or every time its lease expired? We would need to update our DHCP settings with the new IP address every time it changed. I can't think of a single circumstance where you would want to do this. It's much less complicated to simply assign a static IP address to our DNS server so it never changes. Another example would be printers or scanners. You want these devices to use a static IP address so people would be able to consistently print to them and not need to re-enter the IP address every time its lease expired. Now earlier we talked about making reservations where DHCP would assign an IP address to a specific MAC address. You might be wondering why we would take the time to log on to each client computer and manually configure a static IP address when we can simply create a DHCP reservation from a single server. There is one major difference, and that is if your DHCP server crashes and you manually logged on the computer and set a static IP, that computer will not lose network connectivity. On the other hand, if you create a DHCP reservation, that client computer is dependent on the DHCP server. If the DHCP server goes offline for any reason, whether it's a crash, a network connectivity issue, maybe a switch goes down or a cable gets cut, then that computer will lose its DHCP configured IP address as soon as its lease expires. So basically the server is only up for as long as the DHCP server is up. Obviously, the point of DHCP is to make life easier when connecting new devices to a network and getting them online quickly. So generally what happens is that servers, printers, and other things that offer services to a network use a static IP address, a manually configured IP address that is not reliant on DHCP, and workstations or end users, people who are connecting their laptops, their desktop computers to utilize these servers, are using DHCP as their network configuration. So they're the ones getting the IP addresses configured automatically and not servers. Now we've covered a lot of information, so let's recap what we covered so far in this lecture. First, DHCP is a network protocol, and in the Windows world, it's installed as a server role. System administrators can specify a single scope or range of IP addresses for DHCP to assign to clients, and this is on per subnet, so only one scope per subnet. The configurations handed out by DHCP are leased and must be renewed regularly. You can exclude a range of IP addresses, make IP reservations for individual MAC addresses. The technical process of getting client IP addresses is DORA or DORA, Discover, Offer, Request, Acknowledge. Static IP addresses are still relevant for things like servers and printers, and if your DHCP server crashes, computers relying on DHCP will stay connected until their TCP IP lease expires. Finally, if a computer is configured to use DHCP but it cannot find a DHCP server, it will assign itself a private IP address that starts with 169.254.x.x. Great job getting through all this information. You might need to watch this one twice. Check out the quiz at the end of this section. We'll see how you learned, and I will see you in the next lecture.